Now let's do the calculations for our case, for our example with Vada and Riba. Let's find out if the one river is more contaminated than the other. Okay. Well, let's start again for the standard error, calculation of standard error, because in our case the sample sizes are the same, and we assume that the variance of the population are always also the same because our standard deviations are pretty close to each other. We can calculate it using this S1 squared plus S2 squared, where S1, let's start, S1 will be the Vada and 2 will be the Riba. And then divided to n divided to. So if we do calculations, we will get approximately 4.3. So this is our standard error, 4.3. Now the difference between M1 and M2 is 15152.1 minus 139.3, which gives us, again, approximately, in this case, not approximately, of course, 12.8, because we have rounded the values, okay? Now the t-value, it's the ratio between the difference of our sample to the standard error we have calculated, right? So it will be 12.8 divided to 4.3, which gives us 2.97, which is quite extreme, right? Which is quite extreme. Now let's consider all three cases, okay? So we have a distribution, t-distribution, this is density, okay? Then I will make two more plots, t, ft, and then t, very schematically, of course. Let me draw the distributions again, very schematic. So we have three equal distributions, okay? And of course, we need to know the degrees of freedom, right? So which degrees of freedom this distribution should be made for? We know the degrees of freedom. We have n-1 in the first case, n-1 in the first sample, plus n-1 in the second sample, which gives us 18 degrees of freedom, okay? Now think, let's start with the case where we assume, for example, that mu1 is equal to mu2. Okay, this is 0. This is t-value equal to 0, and then we have some variation here. Our t-value is 2.97, so it's somewhere here, And then because it's equality, we also have minus 2.97 here, because both, if we are talking about samples as equal as ours, or even more, both values will be equally extreme, right? So the p-value will be, in this case, this area. And you can assume that the area will be very small. So the p-value will be very small as well, okay? Now let's assume that the Vada is larger or equal than Riba. The average chloride content in Vada is larger or equal than Riba, right? Again, we have 2.57 here, And you remember, in this case, the extremeness is this direction for the extremeness, because if we assume that the difference is positive and sample difference is negative, then it's extreme, and the bigger negative value you have, the more extreme it is, right? So it means that if we want to find out the probability to get a value as this, or even more extreme, this is the area. So you can assume that the p-value will be very large in this case and will support this null hypothesis. And if we have used this null hypothesis, mu2, and then this is our t-value, 2.97. Then we use a right tail, and that will be the p-value. If you look at these drawings, and then let's call this will be the p1, this will be the p2 and p3. Okay, the p-values that we get in all these cases. You can see that first of all, p3 will be 1 minus p2, right? We just use the same t-value, but different tails, okay? And likely p2 will be 1 minus p3, right? Then what about p1? You can see that p1, it's 2 times of p3, right? It's 2 times of this area. So p1, it's 2 times of p. Let's check this with calculations. I will just use the CDF function. I will just use a CDF function for t distribution, so I have to write it like this. So, for example, to get the p2 will be q pt, the CDF function for t distribution, 2.97 and then 18 degrees of freedom. And then p1 will be P2 will be, P3 will be 1 minus P2. And then P1 will be just double of P3. So it will, we just need to calculate only one value using the t-distribution. So if we do the calculations, we will get 0.996 here, 0.996 here, okay. We will get 0.04 here, 0.04 here, 0.04 here, and then it's doubled, right? 0.008, okay. So it means that you have, in this case, only 0.8% chance to get a sample like we have, or even more extreme if null hypothesis is true. So we reject null hypothesis. In this case, 99.6% chance to get a sample like we have, or even more extreme if null hypothesis is true. And of course, we support it in this case. And then in this case, the 0.8% chance, 0.4% chance, of course, that to get a sample like we have, or even more extreme if null hypothesis is true. So we reject this null hypothesis. So the test shows us it seems like Vardar River is more contaminated than Ribe River. Of course, we're never 100% sure, but at least the sample was too extreme from being taken from population with other null hypothesis. So that's our decision in this case.